to the another session. In this session, we're going to talk about the talk, which is about the JSON way to secure your infrastructure, Kyverno-JSON. So before we get into understanding what do you mean by Kyverno-JSON or what do you mean by the JSON way to secure your infrastructure, there are some prerequisites that I would like to present in front of you before we proceed with the beginning. All right. So and the main thing that is getting highlighted here is Kyverno-JSON. Correct. So we need to understand what you mean by Kyverno-JSON at the very first place, and what do you mean by the title of this talk, which is about the JSON way to secure your infrastructure. Cool. Without any further delay, let's get started. So who am I? My name is Nitish, and I am working as an intern with Nirmata, the creators of the Kyverno project. I have also been a Linux Foundation mentee with the Kubernetes release engineering team. And I've also spoken at various conferences, out of which KubeCon, the most prestigious one, is the one I spoke last year in Chicago. And if you would like to get connected with me after this talk, feel free to reach out to me on either LinkedIn or Twitter. My username is @NitishY on all the platforms, even on the GitHub as well. All right, without any further delay, let's get started. So you already know about the talk title, which is the JSON way to secure your infrastructure, Kyverno-JSON. But now you would ask me, what do you mean by Kyverno at the very first place? There can be some folks who do not know about Kyverno, so it becomes very important for them to tell them basics of what Kyverno is. So in order to understand Kyverno, we need to know something. And now imagine what do you mean to say is that. So Kyverno is a policy engine that is for your Kubernetes cluster. And what do you mean by policy? Policy are generally some set of rules that you define, and based on whatever resource that tries to enter your Kubernetes cluster, the policy is going to check whether that particular resource which is trying to enter your Kubernetes cluster is a valid or not. That's what Kyverno policy engine does under the hood. So what Kyverno does is that it's going to have multiple policies for you all, and based on the policies and based on the resources, for example, when you have a resource something like pod, so based on the policies that you have, Kyverno is going to check whether this pod should enter your Kubernetes cluster or not. So it's going to give you some failing checks or passing checks based on your policy and your resources at the same time. So how should I tell you in a better example about what do you mean by policy, and what do you mean by the Kubernetes cluster? So I generally give this example a lot of the times. So imagine you are a kid, okay, or imagine there's a person who goes to the school, or imagine you are the person who goes to the school, correct? So your school is a Kubernetes cluster. You as a student who is going to the school is a resource, and you might have noticed that whenever you try to enter the school, there are generally the school guards that are standing in front of the gate, and they generally check your ID card. So if you have a valid ID card, then only they let you go inside the school, otherwise you won't be allowed to go inside the school. So your school is a Kubernetes cluster. You are a resource that is trying to enter the school, which is the Kubernetes cluster, and the school guard is a policy. So this policy, the school guard has a policy. A school guard is like a policy that is going to check whether any student who is trying to enter the school should have a valid ID. That is what a generally policy means. So if you or if any Kubernetes resource like pods, deployment services do not have that specific requirements as mentioned in the policy, then they won't be allowed to enter the Kubernetes cluster. That's what Kyverno does under the hood. So Kyverno also have multiple policies that you can use, and based on all the policies and your resources, you're going to get multiple checks. You're going to get validation checks. You're going to get mutation checks, and you're going to get a lot of other things as well. We're going to take a look at this as well. This is going to be something like this thing. For example, if your pod is trying to enter the Kubernetes cluster and the policy says that there should be no pod with host path set to enabled. Cool. And imagine this yellow pod is having your host path set to enabled. Then it won't be created inside the Kubernetes cluster. Kyverno internally will create another pod that has host path set to disabled. That can be done mutation, or Kyverno is going to validate whether this pod is that you are trying to create should whether be created or not. So if that pod has host path set to enabled, it's generally definitely not going to create the pod or the resource. Cool. Now let's get understanding and trying to understand what is the problem statement now. So Kyverno is actually Kubernetes native, and now with platforms going cloud native, there are a lot of security risks that evolve over the time as before. Cool. So it becomes very important that have your infrastructure secure, and most of the times your infrastructure is built upon the cloud, and you are using the cloud configuration files, and depending upon your infrastructure, you might be using Docker files as well, or you might be using the Terraform files at the same time. Now the fact is Kyverno is Kubernetes native, but you might ask me, okay, what if my platform contains cloud configuration files, Docker files, Terraform files, and so on? Can I still use Kyverno to have these policies and check whether my certain there are no certain security risk? Just like I mentioned you about that Kyverno will check your Kubernetes resources against the policy. So can Kyverno even does the same for your other configuration files, such as maybe Terraform files, Docker files, etc.? The answer is no. But in short, the answer is no. But what we are doing now is we are trying to extend the Kyverno one level above. So now Kyverno is Kubernetes native, but now we want to work on more things outside the Kubernetes. So imagine your infrastructure again is built on the top of these cloud configuration files. So who is going to solve these problems? What if your configuration files have some security issues? For example, one example can be, what if your S3 bucket is publicly accessible and your private data is getting leaked out? That's a security risk. So imagine you have a Terraform file that is having some properties of public access buckets enabled, and you don't know about it, right? You are unaware of this thing. So eventually there should be some sort of policy that is checking in your whole infrastructure whether there exists any sort of Terraform file that has publicly S3 buckets enabled or not. So depending on these type of policies, you will get passing or failing checks, and you will get to know, okay, this is something that can create the vulnerability in the future time. Cool. Let's move ahead. And what's the solution? Introduction to Kyverno-JSON. So Kyverno-JSON is that CLI tool, or you can say the tool that you can use to validate and check your resources which are not Kubernetes native against specific policies. But don't confuse Kyverno with Kyverno-JSON. Kyverno-JSON have a little bit other syntax for writing the policies, whereas Kyverno has some little bit other syntax for writing the policies. Cool. We're going to take a look at what Kyverno-JSON does. We're going to take a look at mostly in the demo part. Don't worry about that. So we're going to take a look at it on the short basis. So imagine you have a configuration file, and this configuration file needs to be a JSON payload. So what if you say that I have a Terraform file. So you need to convert that Terraform file you need to get a JSON payload of the Terraform file, and you need to pass it to the Kyverno-JSON, and then based on some set of policies. Now you will ask me that where can I find these policies? Who has written these policies for me? What if I want to write these policies for myself? How can I write these policies for myself for my own use case? So we're going to take a look at this as very shortly in the time. So imagine you have a JSON payload, right? And you're going to pass it in the Kyverno-JSON. So based on the policy and based on the configuration file that is your JSON payload, you're going to get pass or failing checks. Important point that you need to understand here is that you need to pass the JSON payload of your configuration file to Kyverno-JSON against the policy. We're going to take a look at where you can find these policies, and based on the resource you have provided, the policy will give you passing or failing checks. That sounds good. And now you might have got bored up till now, so you might be having some questions. Show me where are these policies and how to use them. So let's proceed with the demo time now. What are we going to cover in this demo time? It's literally going to be very interesting, so make sure you watch that entirely. So we're going to understand two main things: how to use these policies, and that covers like where can I find these policies, what is Kyverno-JSON, where can I find the important links that I want to see, and the other thing is how to write the policies. What if I want to write my own custom policy? What is the approach that goes behind writing Kyverno-JSON policies for my own use case? And when you're trying to understand how to write the policies, you need to understand one important concept that comes here is JMS path expressions, or JP, because you are eventually trying to play with the JSON payloads. And you might have even question, what if I have my Docker file? I'm going to convert this Docker file to a JSON payload. So we're going to take a look at this as well. All right, yeah. Let's get started then. Cool. So this is first of all the link, that is Kyverno/Kyverno-JSON, and this is the description already says that Kyverno for any JSON. So it is going to act as a Kyverno for any JSON payload. So you can just take a look at it, and you can see that you can have Terraform files, you can have Docker files, you're going to have cloud configuration files, and other thing as well. If you go through the documentation, if you see the quick start guide, that's basically the quick start guide, but I'm going to tell you about the introduction. So it generally says that Kyverno-JSON extends Kyverno policies to Terraform to perform simple and validation operations on JSON or YAML format. So if you have your payload in JSON or YAML, you're good to go. Cool. And you can just read through it that it comes as a CLI, and then also as a REST API, and then the library is there for it as well. If you go through the quick start guide, we have certain example for you that, for example, this is a payload, correct? And now this Terraform file, you need to convert it into what? You need to convert it to JSON, because you need to parse this JSON to Kyverno-JSON. So you're going to do that. You can do that with the help of Terraform show command, and then you're getting a JSON out of it. Cool. And then once you have got a JSON, we're going to have another policy. This policy is having some, don't worry about that. This policy is having some check statements. It's checking something, and based on these things, it's determining whether your certain fields exist or certain fields and values matches in your payload or not. And based on that, you're going to get passing or failing checks for the policies. And the main thing that I want to mention here is that if you go through the policy section here, you can see that we have some policies, but don't worry about that. We're going to have a list of policies that are already being written, and these will be pushed soon to the GitHub repository. Where can you find these policies? You can find these policies at Nirmata/Kyverno policies. So when you will be watching this video, you'll be having something like Dockerfile best practices. So Dockerfile best practices will contain all the Kyverno-JSON policies that you can use. Okay, so it's under Nirmata/Kyverno policies. That way you can find all the policies for Kyverno-JSON. What if you want to find the policy for the Kyverno? You can just search on Google like Kyverno, and you can get a lot of policies for Kyverno. So policies that are Kyverno and policies for Kyverno-JSON are specifically different. So that needs not to be confused. Cool. There's one more thing that is I want to mention a lot is playground. And this is the main thing that I want to mention here. So you have a playground, and you can see on your left is your YAML format input, or you can have even a JSON input. It's okay for that. So this left side is going to contain your payload, okay? Whereas your right side is going to contain your policy content. And then based on your policy and based on your payload, you're going to run this, and it's going to give you some errors, or not errors, but it's going to give an output here that will be shown. So whenever you're trying to write your own custom policies, it's always recommended that you use a playground, because playground has the latest version, and sometimes when you're trying to test locally, you might not have the latest version installed. That's too much talk. Let's get started now. Cool. I mean, we are already started, but yeah. Cool. As you can see, I have a specific payload here. I think I can show you a better one here. Oh, okay. I don't have a better one, but never mind. All right. So I can move to the VS Code, and I can tell you about some of the policies that we have written so far. So if you go to the AWS, don't worry, these policies will be available on the Nirmata/Kyverno policies folder. You can find it here. So if I go through the AWS S3, and imagine I want to, I want to check for S3 versioning. So what it does is, for example, if I go to the README file, you can see that it's saying that versioning in Amazon S3 is a mean of keeping multiple variants of an object. And this is something that we need. So imagine your infrastructure is built on the AWS, and you want to make sure that your S3 bucket has versioning enabled. this is your use case, correct? How are you going to do that? So we have written a policy for the same. Okay, we have written a policy for the same. What I'm going to do is I'm going to come here and I'm gonna just paste it here. All right, and we have some tests as well. So for example, if you can see, you have a good terraform.tf that generally has, you know, this versioning configuration in which the status attribute has been set to enable, which means that whenever you're trying to create, you know, AWS S3 bucket, the versioning will be set to enabled or disabled depending upon your status field. So with the help of you know, Terraform show command, once you have built the binary, how can you build the binary? As mentioned here, we have a Terraform file now. You can, you know, build the binary. So I'll just show you. You can build, you can see, you can have the Terraform and you building the binary, and then you're trying to get a payload. Similarly, we have got a payload which is called as good payload. Good payload means it's like it's a good payload. It's the good practice that you should follow. So I'm going to just copy this and I'm going to just paste it here. Let me do that. Cool. And this is a payload and this is a policy. So if I try to run this now, let's see, it's saying that your result is passing. What is happening is that, you know, you need to make sure that which field is actually getting affected. So if I see that, you know, where is my status, because status is the main field. So you can see that if I search here status, you can see here is a versioning configuration as status as enabled. Cool. It means that this is what we want. If we want our versioning to be enabled, which depends upon the status, so it should be enabled, correct? What if I change, and your policy is going to check whether the status is enabled or not. If it is enabled, it's going to give you passing checks. If it is disabled, it's going to give you failing checks. So if I change it to disabled, now it should fail. And if I run this, you can see it's saying the failing, and the message it's saying is that S3 bucket version needs to be set to enabled, which is giving you the correct error message that this status needs to be set to enabled. That's a one use case. Okay. Now you might have a question, how did you write this policy? We're going to come over that as well. But before understanding another thing, I can give you one more example for this one, which is about this thing. So we're going to check the certificate validation. So whenever you're trying to, you know, run the curl command and you're trying to install some certificates, you need to make sure that these certificate comes from a valid, these certificates are validated at the first place. So we have written a policy for the same, and if I run it, you can see that it's getting passed. What is the field that is getting affected? So you can see that we have a description. This policy checks whether certification validation is disabled in the Dockerfile using -- insecure option, which means that if you're using -- insecure flag or the option, then your certification validation is going to get disabled. Cool. So we need to, you know, not use the -- insecure option. So if I go here and if I try to see, you can see that I'm not using any -- insecure when I'm having the curl command. When I'm using the curl command, that is the reason it's giving me passing checks. What if I have the thing something like curl -lo, and you know, I'm going to use -- insecure. This means the certificate is not valid. Don't check the validation of the certificate. Okay, I will run this and it's giving me failing checks. Why? Because it contains a -- insecure, you know, the option. This is a use case. So whenever you're trying to install the, you know, whenever you're trying to install some certifications, you're trying to install some packages using curl command, and imagine when your infrastructure you have by default you have a -- insecure option, and you try to run this policy against in your infrastructure, it is going to tell you that, you know, you need to make sure that your certification validation is enabled. That's another use case. Cool. So we have a lot of use cases that we can definitely see, but all these will be pushed to the Nirmata/Kyverno policies, which is this repository. So make sure you keep an eye over it. All right. The main thing that comes here is that, how do you write these policies now? Like how do you write these policies and XYZ things? And in order to write these policies, you need to make sure that you understand a little bit of JMS path. So JMS path is nothing. It's like you have a JSON payloads, and you need to manipulate, or you need to check certain data field in your JSON payload. And in order to fetch a certain data from your JSON payload, from a big JSON payload, and you want to get certain field, JMS path is the way. So JMS path stands for like the JSON path expressions, and it has certain expressions that you can use, you know, to get your specific data. For example, here you're trying to say that locations is an array. As you can see, locations is an array, and we're going to get an element or an object that have state is equal to WA. So which is the state that has WA? This is the one, correct? And then we're going to sort it on the basis of the current element, and that is the reason we got this one option. Yeah, I hope that makes some sense. All right. Okay, so highly recommended that you explore a little bit about JMS paths so that you can get an understanding about how do you do that. I mean, how do you write the policies? But let's see about this policy. What is the thought process that goes behind? So imagine, first of all, the thing is I need to check here that I need to check about the status field. Cool. So here's the status field. Yeah, here is the status field and it is set to disable. So now the first thing that comes here is that these are some of the annotations that you use. API version, kind, metadata is like that's what happened in Kubernetes as well. But the main thing is starts from here. You have a spec section and you have a rules. So rules is like, this is the first rule that I'm going to check. So the name of the rule is, check S3 versioning setting, which means to check this status. If the status is set to enable, we're going to pass the policy. If the status is set to disable, you're going to fail the policy. Cool. Then we have another thing which is called as a match section, and a match section has all in it. All means like you can have multiple match statements, and then its Kyverno-JSON is internally going to check all the match statements. If you have any here and you have multiple match statements, then if any of the match statement gets true, your policy will be evaluated. But imagine you have all in the match statements and you have multiple match statements, then if any of the match statement gets false, your policy is not going to get validated against your JSON payload. So what we're doing here is that we're going to say that inside your planned values.root module.resources, which is something like this. This is your planned values, okay, and this is your root module inside your resources. Resources is an array. That is the reason we have written it like this thing. Search for a resource that has type AWS S3 bucket. So do we have a type AWS S3 bucket? AWS S3 bucket. Do we have a type? Yeah, we do have a type. We do have a type something like we do have a type something like AWS S3 bucket. So if this match condition is true at the very first place, if this match condition is true, then only the other things are going to get evaluated. If this gets false, if I say something like this, and if I try to run this, you're saying that result is null. Why? Because your match is not getting true. So your match statement should always be true, and then only the another statement, which are assert statements, going to run. Cool. So what is this thing we are doing? We are using just a piping symbol. For example, whatever the array, whatever the resource that we have got, we're going to check is length greater than 0, which we mean to say is that if you find any resource, then it means the length is going to be greater than 0, correct? And if you have got a length greater than 0, then the right side is going to be true. So right side is expected value. So here it's going to be true, and here it's going to be true. Then the overall expression gets true, and that's when we move to the another statement, which is called as assert. Inside the assert, we have two check statements, which is again using all. So if any of the check statement gets false, for example, if this check gets false, the policy is going to give you this message. But if you use any here and imagine only this gets false and this check statement is true, then you're going to get a true because you're using any. Any means like if any of the true statement, then return that true statement. All means all the checks should be true. So we're going to have a first check statement which is saying that use the AWS S3 bucket versioning resource. So it's saying that you need to use AWS S3 bucket versioning. Yeah. So it's saying that you need to use this resource block. What if I don't have this resource block? Then your policy is going to give you failing checks. Okay. And the second check statement that generally says is that you need to get the status value set to enable. So how are we going to do that? Again, we're going to iterate over the root module.resources and we're going to check this one. This is a type. I mean, this is the resource we want to get. We want to search for, and what is a specific field that differentiates it? It's a type. Cool. So we're going to say that search for this type, and then we are going to iterate over. So we're saying that values is an object, and then we're saying values dot versioning configuration is an array, correct? And then we're checking that versioning configuration, check that element which has a status field set to enabled. If you find any element that has status field set to enabled, then it means it is true, and the right side is also true. Then return the true. In means simple thing. If you find any object that has a status field set to enable, then return true. But here you can see there is no such object. That is the reason we got a length which is equal to 0. So this statement is eventually false. And false is on the left side, whereas on the right side it's true. Both are not matching. That is the reason when you try to run it, it's going to give you failing checks. What if I have it as enabled? If I have it as enabled, the left side is going to give it true, right side is going to give it true. Both are true. It's going to give you passing checks. So that's how you basically have your policy written. I would highly recommend that you explore the JMS path. You also explore the Kyverno/Kyverno-JSON. And the next thing is, the last thing that I want to mention about is how do you convert your Docker files to JSON payloads. For example, this Docker file is converted into JSON payload. So for that, you can use our CLI tool, which is called as NCTL, or the Nirmata CLI tool. So we have a documentation here as well. You just need to install the NCTL, and based on the commands, you can convert your Docker file into JSON payload. So in an ideal scenario, it will be looking something like this. You can use the NCTL scan command, and then you're saying Docker file, and then you're passing the -r, which is the resource, and you're passing the Docker file path, and then you're passing the option which is -- show JSON, and then you're storing the data inside a file. That's how you convert a Docker file into a JSON payload. Cool. And I think that's it. So make sure you explore this, and all the policies will be actually pushed to the Nirmata/Kyverno policies. So keep an eye over it, and you will get to know how to test these policies as well. Cool. One specific advice that I can give you for writing your own policies is always consider the edge cases, and try to see what is a field that is going to get manipulated. If you change this field, this is a field, then this is the result that you'll be getting. And based on that, get your JSON payload, and then it's a JMS path expressions only. If you figure out how to write the JMS path expression, the rest is very easy. Also, you can go through the Kyverno-JSON documentation, and we have a writing policies. Let's just search here, like how do you write the policies here. We have assertion trees. Everything has been mentioned here already. How do you do that? So make sure you take a look here as well. And if you have any doubts, make sure you can reach out to me at Nitish on Twitter or LinkedIn, wherever you want to. You can also join the Kyverno channel on the Kubernetes Slack. The invite to the Kubernetes Slack is slack.kh.io. So make sure you join the Kyverno channel, and we'll be happy to assist you if you have any doubt further. And yeah, that was it for the presentation, and I hope you like this talk about the JSON way to secure your infrastructure. And if you have any doubts, feel free to reach us, and we'd be happy to answer you all. Thank you.